Hello, today we are working on lesson 39, and we are going to talk a little bit more about what it means to have imaginary roots in our functions, and we're going to start tying them into graphs. So our video notes are lesson 39, and you can title them Factoring Extended to the Complex Realm. And we are going to use vocabulary words like conjugates, real numbers, real roots, imaginary numbers, we're going to talk about I a lot. We're going to do a little bit of U substitution, and we're going to use box method and FOIL, and we're definitely going to factor, just like we've been doing for most of the year. So we have 3 examples today. Ooh, maybe 4. The first one is, here are the directions. So let's read the directions and let's mark up the directions however we need to annotate. Completely factor the following polynomial expressions. Well, I only have one polynomial expression, but if you got a question like this and you read the directions, you'd have to factor. So some of you feel like factoring could mean many things. For some of you, it means breaking into 2 binomials. For some of you, it means taking out the GCF. And for some of you, it may even, like in this case, start with the solution, and then we move into the factor. For example within the example, if my solution was x is equal to 3, and this was my root or my solution, and then I want to write the factor would have parentheses around it usually, and it would be x minus 3. So we would take our solution or our root, and we would move it over to the other side of the equal sign, and we would have a factor. So let's try that approach where we find a root, and then we will be able to write the factor for it. And that's how we are going to factor this today. Okay. So let's find the solution, and then we'll change it into a factor. If you're annotating, that's what you can write down. First, we are going to find the solution, and then we are going to make a factor. So if I made this equal to 0, and I subtracted 7 on both sides, I would get x squared is equal to negative 7. So far, so good. I'm not scared to take the square root of negatives anymore because I have imaginary numbers on my side. So I have x is equal to plus or minus 7 times negative 1. So I get plus or minus root 7 times I. Because my negative 1, if you are annotating this as well, your negative 1 is going to turn into I. So these are my 2 answers. Now, if these are my answers, let's make them into factors. So if x is equal to, let me change the color. If x is equal to positive 7i, then my factor is going to be x minus 7, root 7i. And if I have x is equal to negative root 7i, then my factor is going to be x plus root 7i. Now, what does this look like? We have a positive version and we have a negative version. If you just looked at the radicals without the I, maybe you'd be able to tell me that this is the conjugate. It's coming back. It's like we're using it. And we learned it, and now we're using it and applying it to another concept, which is exactly what we're going for. So this is a conjugate. This is going to help us. This tells you if you have a conjugate, if you multiply the conjugate together, if you multiply x minus root 7i times x plus root 7i, you are going to end up getting, instead of x squared minus b squared, because it's going to be bi squared, I should write that down, but I'm not going to, bi squared, and you're going to end up getting x squared plus 7. But we're going to do a lot of this in class, so this is just taking notes on it, and then you're going to practice this in class. Let's move on to the second example. Consider the polynomial p of x. That's how you read that. You read it p of x. That's how that's read, p of x. Is equal to x to the 4th minus 4x squared minus 5. What are the solutions? Okay, so when you come across, you're like, okay, this kind of looks like a quadratic, and we might be able to use quadratic equation, which would work in this situation. almost. Or you would factor, and then maybe you want to factor, but then like, how do you factor x to the fourth? Or what I think, if I did this, something to the second power minus 4 times something minus 5 is equal to 0. If you saw this, you would be able to factor this. Like if I did u squared minus 4u minus 5. So then you have to declare what is your u. U is equal to x squared. What squared will give you x to the fourth? And you can say x squared. And then negative 4 times what will be negative 4x squared? And you can say u can equal to x squared. We're doing this because now that we have a quadratic again, something squared minus something minus 5, we can factor this into 2 binomials. And then we should end up getting negative 5, and we should get positive 1. Yes. Okay. And now we can solve 2 equations. U minus 5 is equal to 0. U plus 1 is equal to 0. So, but what is u? Let's go back and replace our u's. U is going to be x squared. Whoa, go back. X squared. So I have x squared and x squared. Now let's solve. X squared is equal to 5. Take the square root of both sides. I get x is equal to positive and negative root 5. Now I'm going to subtract 1 on both sides. X squared is equal to negative 1. Take the square root of both sides. That negative 1 does not freak me out because I have imaginary numbers on my side. Nice. All right. So I have x plus and minus root 5, and I have x plus and minus I. So those are my 4 solutions. I have 4 solutions. Positive 5, positive root 5, minus root 5, positive I, minus I. Now, that goes into the second part of this question, which you should be writing down. How many x-intercepts does this graph of the equation x to the 4th minus 4x squared minus 5 have? X-intercepts. What are the coordinates? So, okay, we usually, x-intercepts mean that you have some x value and then the y value is 0. So the coordinates are going to be some x value and 0. The thing is, we've always talked about x-intercepts as being solutions, but now that we have our imaginary numbers and we're working with complex numbers, the x-intercepts are not always all the solutions. The x-intercepts are going to be the, ready for this? The real solutions. Because when we graph our p of x, it's going to be on an xy plane. We're not graphing it on that complex plane. So our real solutions, this is not real, this I is not real, this is real, are going to be our x-intercepts. So let's see, we have our solutions. I'll put real solutions. And then we have our factors. So x-intercepts are our real solutions. I guess we don't need to do our factors right here. So which ones are our real solutions? We have x is equal to positive root 5, and we have x is equal to negative root 5. So the coordinates would be root 5, comma 0, and negative root 5, comma 0. Okay? Go back and annotate, highlight, star. Our x-intercepts are going to be our real solutions. And then in a couple days, we're going to talk about what happens, what are we going to do with those imaginary roots. Okay. I'm going to pause right here before we move on to our last example. So at this point, you should summarize part 1, summary. And then I will meet you on the next video to do part 2. Bye.